document too.
Which document?
This midterm for us to study with.
Now, is this what you were talking about doing?
No, iCloud Drive.
I wonder how to do that. Do we know how to do it? All right. Well, so let's go over this. First of all, whatever number's on your test currently, you can add 7 to it. So that makes our highest grade a 105. Our low grade,
12.
no, I don't think it was a 12.
I thought you said it was 15.
No, there was somebody lower.
Lower than a 15?
Yeah. I think the low grade was a 10. That was with the 7 points. You also have to keep in mind that if you divide 100 by 14, I actually give you free points for your name.
Yes.
Class average was, I think, about a 77 with the 7 points. With the 7 points. Class average was a 77. Okay, so let's go through this. What is a primitive type? List all of them. Primitive type is a type built into the language that is capable of only holding a value. What are our primitive types? Byte, short, int, long, float, double, char, Boolean. Not strings, not object. I tended to grade it fairly loosey as long as you gave the right answer for what a primitive type was. If you listed several things that were primitive types but missed a couple, I didn't hit you much. If you started putting wrong information in there like strings and cows, you probably lost points. Goats. All right, questions on that one? All right, so now the next one, this is where I get to yell at you. How many times did we go over how do you call class methods? How do you call instance methods? How do you identify a class method being defined? How do you identify a class method or an instance method being defined? Not once, right? Would you say at least once per class? At least. It was appalling how many people missed these. How do you identify an instance method from a class method if you are looking at the method definition? The method definition will contain the word static if it's a class method. It will not contain the word static if it's an instance method. That's if we're looking at the definition of the method. Make sense? Like 30% of the class missed that. I don't even get it. How can you identify an instance method from a class method if you were looking at the method being used? Class methods are called using the name of the class in which the method was defined. Instance methods are called using an instance of the class in which the method was defined. So, class name followed by the name of the method with a dot in between if you're calling a class method. An instance of the class, for instance, if we're calling a string method, we might say s dot if s was an instance of the string class. Okay? Important thing to point out from some of the borderline answers. All instance methods are not string methods. Strings just happen to have instance methods in them. Okay, there are other classes that will also have instance methods. All right, questions about that? So 3 and 4, there should have been 0 points lost for everybody in here. 0 points lost.
2 and 3.
Huh?
2 and 3.
And 3 and 4. 2 and 3. Yeah, 2 and 3. 2 and 3, 0 points lost. Definitely 0 points lost. So you should really struggle internally if you lost points on those as to why. Maybe pay more attention in class. You didn't even have to pay great attention. Just sometimes you would have picked up on it. All right, number 4. What is a variable and when should we use them? A variable is how we simulate memory. It's how we store something. It's a named name-value pair. Something like that. Okay? When should we use them? Whenever we need to store a value and use it again. So whenever we're going to use a value more than once. Make sense? Let's see. What is a method and when should you use one? A method is a reusable chunk of code. When should we use it? When we need to call a chunk of code more than once. So whenever you need to accomplish a task more than one time, you would define it in a method and then call that method each time you needed to accomplish that task. Make sense? Questions on that one? Let's see. Number 6. People miss this one. I know! What is a Boolean expression? It's any expression that boils down to a single value of true or false. How many times per class did we mention that? These are free points. Let's see. What is the difference between an if statement and a loop? If statements execute the body once, potentially, if the Boolean expression is true. Loops continue to execute the body over and over again as long as the Boolean expression is true. So an if simulates asking questions. A loop simulates repetition. Something along those lines. Make sense? All right. What are the 3 different kinds of loops and what kinds of problems does each type lend itself to? 3 loops. We have a while loop, a for loop, and a do while loop. While loops are pre-check loops. They lend themselves to problems where we do not know how many times we need to spin. An example might be press any key to continue. If we press any key yet, if we press any key yet, if we press any key yet, so on and so forth. For loops, also a pre-check loop. They are used for counting type problems. They lend themselves to counting type problems or problems where we do know how many times we need to loop. Okay? Do while loops are post-check loops. That is, we ask the Boolean expression after we execute the body at least once. They lend themselves to problems where we need to do something at least one time. For instance, authentication. That makes sense? Some of the answers I got for that one were just crazy. I mean, like some of them like, well, if we need to loop, we use this guy. If you don't need to loop, you use this guy. They're all loops. Yeah, I laughed at some of those answers. Make sense? Oh, and strings are not loops. I know. Write a class method named reverse string that takes a string as a parameter and prints out the string backwards. I need to restart Eclipse, yes. Very exciting. What's up? I'll say we're doing good stuff now. Cannot find SDK, Android, that's fine. That's fine. All right. Hello.
That's interesting. Buggy much?
Why don't we give this boy one more shot?
All that Yosemite.
Yeah, too much Yosemite.
How dare you? Yosemite.
Are you recording this?
I am.
Damn it.
Hey.
All right. So, static, void. What do they call it? Reverse string. Okay, we're going to return a void because we are printing the string in reverse. Printing it in reverse. Okay. Now, first of all, this was something I saw commonly. Or something like that. Somebody's going to call this method and pass you a string. You don't get to hard code in what the input's going to be. Okay? You just broke your method by doing that. Right? S holds a string, it holds some string. And what's the length of the string that S holds? S dot length. So we're going to create a string called answer. We're going to write a loop. And the loop's going to start at S dot length minus 1. Keep going as long as I is greater than or equal to 0, and subtract I each time, because we're going to walk that string from the end towards the beginning. Each time through, we'll concatenate on s.char add I onto answer, and in the end, we will print out answer. So this is going to take a string as a parameter. We're going to build a brand new string. We're going to spin through S from the end, S.length minus 1, the last legal position, all the way to the beginning, including 0, the first legal position, subtracting 1 from I each time. We'll concatenate on each character onto answer, and ultimately, after the loop is done, we'll print out answer, which should be our string in reverse. Oh, I never actually called it, but that's legit enough. Oh, first of all, notice this guy is a class method because when we defined it, we put static out front. So we call class methods using the name of the class in which the method was defined. So HW dot reverse string. We'll pass it hello. And there's hello in reverse. You could have also done this without building a new string and instead just printing out s.char add I. This would have put it 1 character per line, but not the end of the world. And there's hello backwards. If you wanted to be fancier about it, you could have left the ln off, and that would have put it all on 1 line. Any of those would have been acceptable. Questions about that? So, the most important thing I first looked at when grading those is method header. First of all, I asked you to write a method. So all you needed to put in your solution was that. You didn't have to write the whole program. You didn't have to show yourself calling it. All you had to do was give me the method. Make sense? So I looked at method header. Many people put string here. which wasn't immediately wrong because I didn't necessarily say you couldn't return the string, but then I was very interested to see if you indeed printed the string. And if you remember correctly, when I gave the exam, I specifically said, pay attention to number 9. It says to print the string, not return it.
What if we returned it and then printed the return?
That wouldn't be legal because I only asked for a method.
Oh, okay.
Right? All right. That was number 9. Number 10 and 11. Again, freebies. How do you call class methods using the name of the class in which the method was defined? How do you call instance methods using an instance of the class in which the method was defined?
How are 10 and 11 like different from 2 and 3?
2 and 3 is how can you identify them at the, well, 2 is how do you identify them at method definition. 3 is how do you call them? How can you tell that something was something if you see it being called? 10 and 11 are pretty similar to 3, except they're asking you how do you call them.
So, like for 2, you would say you call it by, or you can see it by if there's a static in front.
Yeah, because you're looking at the definition.
Okay, and then number 3 is you call it.
How can you tell the difference between it when it's being called?
So
3
is similar to 10.
Very similar to 10 and 11.
Okay.
Difference is in 10 and 11, I'm asking you to tell me how to call it. Number 3, I'm asking you, how can you tell what's being called? How can you tell if you're looking at a method being called, how can you tell me whether or not it was an instance method or a class method based on how it's being called? All right. Questions about 10 and 11? So right off the bat, this should have been, let's see.
7 points per each one.
So that's 14 points, 21 points with the Boolean expression, 35 points. Minimum score on the test should have been 35 points or a 42 with the 7-point curve. Right?
44 because you write your name on it.
Well, I gave you those points free. Those just came with it. So really the minimum grade you should have been able to get is, what's 14 times 7? Should be able to get 2. 2 points. That's if you left the test blank, but put your name on it, you got a 2. Somebody got a 10 on the test with the curve. They got a 1. Yeah. Wow. All right. So that's 10 and 11. All right, 12. This is why we had the curve. I don't think anybody got this one entirely right. Given a char variable named C, so the name of the variable is C. Variables hold values, correct? What kind of value does a char variable hold? Holds a char, single char. Write a single line of code that will boil down to the contents of that variable in uppercase. So, assuming I gave you a char C holding some character. You don't know what the character is, but for this example, I'll go ahead and put a character in there. Okay? And I want you to write a single line that will boil down to whatever is in C in uppercase. So let's make a char a string. Remember, Java's a string-based language, so if we can get anything into a string, it will benefit us because it's very malleable. Now we have it as a string. So now we can take that string and call the strings to uppercase method on it. Okay, which was in our string method toolbox. So now we have the uppercase version of that string. Then we can get the character at bucket 0, which should be the uppercase version of whatever's at bucket 0. Now, what if I put in the number 2? Still works. 2 uppercase, just won't touch the 2. So this string is now in uppercase, whatever that means. Give me the character at bucket 0. So something along these lines is what I was looking for. There is also a method that lives in the character class that we did not talk about. So there exists a class called character that has a method called toUppercase. And that method takes a char as a parameter and boils down to whatever char you passed it in uppercase. Is this a class method or an instance method? Tell me why it's not an instance method. No, I mean why it's not an instance method. This is a class method. Why is it a class method? Using the name of a class to call it. Did I define a variable anywhere in here called character? That's a class name. So I'm calling this method toUppercase using the name of a class. Since I'm calling it with a class, it must be a class method. What's this guy? Class method or instance method? You sure?
Yeah.
Willing to bet your grade on it?
Yeah.
Okay. Why? Because I'm calling it with something that is a string in this case. An instance of the string class. As opposed to the name of the string class for this example. Make sense? So here's an example of me. So this is number 3. How do you identify a method by the way it's being called? This method's an instance method because it's being called with an instance. This guy's a class method because it's being called by a class name.
The class name isn't defined though, right?
Well, it's defined somewhere. We know we didn't define the variable. We didn't write toUppercase. So this method must not belong to this class. We also didn't define a variable named character, which it wouldn't have let us do anyways. So this guy, by process of elimination, must be the name of a class. Or an error. One of the two. Because we didn't define the variable. So it's not found anywhere in our scope for variables, right? So this is either an illegal line of code, or this guy must be the name of a class. The other telltale sign that's the name of a class is that it starts with capital C. And typically, naming conventions have class names starting with a capital letter, even though we didn't make ours start with a capital letter. The name of our class is HW, all lowercase. So it's not a rule, it just happens to be a naming convention. All right. So, questions on number 12. By far the most missed question on the test. Literally nobody got it completely right. The person who got the 105 on the test missed 2 points on the exam, and it was on that question. I think they got 100% in the rest of the exam. So, I'm guessing the wording was either wrong or a little weird, or your minds were just not going in the direction of where I wanted them to go. But clearly, when you have one question missed by everybody, something seems to be up, so I just curved that one back in. So everybody got a free 7 points. Fair? All right. Now, actually, just out of curiosity, now that you've seen the answer, what was the challenge on the question? Was it worded poorly? Now that you kind of see what I was looking for, just kind of in hindsight being 2020, what was the struggle with that question?
We didn't really use it.
No one probably really thought to change the char to a string and then use the two uppercase, and when they probably just thought to use the two uppercase for the char, they probably just forgot to change it to a string. That's what I did.
Well, yeah, but we never actually did this one. Yeah, so this would have been off the table.
Yeah.
I probably would have accepted it if somebody put it there because I was just accepting anything that was close to correct. But this is really what I was looking for, this idea of concatenating something onto a string. So I guess I was really testing on how do you turn a primitive into a string. So it's just kind of not something we did tons.
Yeah.
It seems like we did concatenate on the empty string a lot, but doing that along with calling methods off of that was kind of the...
Yeah, like
We
5
didn't-
minutes on that, I think.
I don't
Okay.
think we actually even used the uppercase in any homework that you assigned.
Yeah, I don't think we did it in homework, but we definitely did it in an example in class.
Yeah.
Once for about 5 minutes.
Okay.
Yeah.
So it was just one of these things that this was common, but using something like that along with calling a method was not.
Yeah. We didn't really do that.
Okay. All right, fair enough. Let's see. 13, what is a pointer? The best wrong answer was somebody drew a picture of a pointer.
I had no idea. I figured making sense of it.
Pointer, primitive type variable capable of holding a memory address. Now, we talked about those a lot. Remember when we were talking about strings and why the double equal sign can't really be used for comparing strings, and we had all those slides that had memory addresses we were pointing up to different places? Remember that now? That was really missed too much too.
Hard concept. Very abstract.
I drew pictures.
Still abstract.
That's why he drew a picture.
Yeah, but see, that's the Okay, so here, as lessons for students. When a professor teaches a concept and then asks, does that make sense? Are there any questions? If you didn't get it, say, what? Don't just chill and then go bomb the test. Sometimes I think I explained something clearly. Chances are, if it went over your head, 5 other people in class, it went over their head too. And the nature of students is not to say anything. You're here to learn, not to bomb tests, right? So who cares if your neighbors make fun of you? I'll make fun of you. So at least you know it's coming. It's expected, right. But don't they say there's no stupid question? I mean, it's even acceptable. I will definitely make fun of you for this. But if you're screwing around in your laptop, which you don't have one anymore, so at least you have that going for you. Sold his laptop, stupid.
I needed a car.
I needed the cash. In any case, if you were screwing around your laptop and just zoned out for 5 minutes, I'm going to make fun of you. But I'd rather you raise your hand and say, I don't know what's been going on for 5 minutes. I'm in a fight with my girlfriend. We're kind of going back and forth. Yeah.
I think one of the reasons also why we don't ask very often is because it happens a lot.
Well, it happens a lot that you zone out or that you...
No, it's just really hard to take it all in so fast.
Well, so then ask.
Okay.
You slow down.
Yeah, and I typically, things that are important, I try to drill over multiple classes, right?
Yeah.
So even if you don't get it 10 times in a row, just keep asking, like, what? Huh? So I'd rather have you ask and me have to come up with some sort of,
Song and dance.
well, not a song and dance, but, some version of the solution that, is made for a 2-year-old that makes sense to you, than have you come in and write some sort of ridiculous answer or draw pictures. He drew a pointer. He drew an arrow and then pointed to the arrow, right?
And I wrote pointer.
Yeah. He almost sort of kind of got it right. But I wasn't convinced that he knew that he got it right. Wow. All right. Yeah, so something, and this kind of goes along with what Nate was saying. I've been teaching programming for a long time. I know it's hard. So I don't expect you to master every single thing I say in the 20 seconds since I said it. But you're going to have a better chance of processing it if at least you have a fighting chance of understanding what I was talking about. So if it completely was lost in you, just say, that didn't make any sense to me. And I'll re-explain it. And then you can lie to me the second time when you still didn't get it. But at least you heard it twice that day. Because you're going to hear it multiple times every single class. All right, I realize this stuff isn't easy. All right, 14, write a method. See, I actually thought I was being nice by only putting 2 programming questions on the test. Because usually those are the tough ones to do on the fly, right?
Well, you can't push the play button and see if it works.
All right, 14, write a method named remove digits that takes a string as a parameter and returns a string with all the numeric digits removed. So this guy's returning a string, so its return type's going to be string. It's called remove digits. It's going to take a string as a parameter, and again, you don't get to set your string to something. Somebody's going to call your method, and they're going to pass a string to it, and that string is going to get stored inside of S. All right, so this is how this method should have started off. Name of the method remove digits, takes a string as a parameter, and is going to return a string. Everything you needed to write this block was included in the text of the question. Write a method, so I'm writing one of those guys, named remove digits, that takes a string as a parameter and returns a string. Make sense? Everything you needed to write this part. And that would have gotten you some points. If you stopped there, I would have given you points. Just wrote a couple of question marks in here, maybe drawn a pointer.
Just draw 0 through 9 with X system.
All right. I get that. All right. So, a couple different ways you'd accomplish this. The way I intended you to accomplish this was, maybe call this map or something. So we're going to go through every character in our string. How many characters are in S? S dot length number of characters. And we want to remove numbers. Remove digits, 0 through 9. That is to say, we want to keep everything else. So if map dot index of S dot char at I, if that guy is equal to -1, that means the current character we're looking at is not one of those, who is not found. Then we'll say answer is equal to answer concatenated with S dot char at I. Return answer. So that was a reasonable solution to this problem. Here's all the characters we want to omit. Put them in a string. You could have actually just hard-coded that string in there if you wanted to. Every single time through, we will call map.indexOf, passing it the character we're currently looking at. And if it returns a -1, that means it was not found in here. If it was not found in there, that means it wasn't 0 through 9, therefore we will keep it. In effect, anytime we do find one that had, anytime we do have something returned other than -1, that means it was one of these guys, and we're not going to do crap with it. We just move on to the next string, the next character. Make sense? All right, so this would probably be the compact way of doing this one. Another way of doing this one that a lot of people chose to partake in. Actually, to make it work for this particular one, if it's not equal to a 0, and,
Oh, you don't do or?
well, it depends. If you are looking at if it's not equal to something, you have to do ands. It's not equal to 0, and it's not equal to 1, and it's not equal to 2, and it's not equal to 3. If it's not equal to any of those, then we'll concatenate it on. You would do ors if you were going to say, if for instance, you could say an or if you're going to say if s.char at I is equal to a 0, or it's equal to a 1, or it's equal to a 2, or it's equal to a 3, then continue. Skip this time through the loop. So if it's equal to any of these, skip. What I'm saying here is if it's equal to none of these. In order to say it's equal to none of these, we have to say if it's not a 0, and it's not a 1, and it's not a 2. Does that make sense, the difference between ands and ors? Kind of. If I threw or in here, so we'll throw an or in here. So now I'm saying, notice I'm saying not equal to. If s.char at I, if the current character I'm looking at is not a 0, let's just say it was a 1. Okay? If it's not a 0, or it's not a 1. Now it is a 1, correct? So this would be false. It is false that 1 is not equal to 1. Is it true that 1 is not equal to 0? That is a true statement. 1 and 0 are different characters, right? So this would be true. This would be false. True or false is what?
False.
True and false is false.
True. Oh,
True or false.
True.
An or requires only one of them to be true. So if that was the case, we would have just kept that one because we used ors.
Oh, okay.
So since it was a 1 we were looking at, which we should omit, if we used ors in here, we would have said, oh, it's not equal to a 0. We're good there. So that's true. It's not equal to a 0. But now we get to the, well, actually, we failed right off the bat because of the way we wrote it with the ors, right? So if it's not a 0, and it's not a 1, and it's not a 2, and it's not a 3, and it's not a 4, and it's not a 5, okay, all the way up to it's not a 9, if it's not any of those, that means we want to keep it. But we need to use ands because all of those Boolean expressions need to be true. Right? It can't be any of them. If it's even one of them, we don't want to keep it. All right? So you would have had to just keep doing the ands, s.char at I, blah, blah, blah. Common mistake people made on this is they didn't put the single quotes around the characters. So this actually was not a syntax error, but it's a logic error. This is going to compare the integer version, the Unicode value of whatever s.char at I is, and it's going to compare it to the 1. Make sense? So, best solution there would have been to leverage the index of method. But you could have written a fairly scary if statement and pulled it off as well. And generally speaking, if the only thing you missed was putting the single quotes around your characters, I didn't take points off. All right, questions on that one? All right, any questions on the exam in general? If you think I ripped you off on points after class, come up and I'll take a look at it, and if I think I did rip you off, I'll give you some points back. If not, I might just laugh, but feel free to come up and challenge if you really think you deserve more points. All right. Oh, let's see.
That's the iCloud version. That's old.
Let's see. So the most recent one is this.
Hey, speaking
Oh, here's your pointers.
pointer.
There you go.
It's like someone draws that entire diagram.
Here's our 2 uppercase method, by the way, from our string toolbox. Okay, so you thought I should be able to.
You should be able to share the link via iCloud.
You only share presentation.
If you go to share in iCloud, you should be able to put it in iCloud, or you may have to go to send a copy first to iCloud.
Well, I should be able to just copy a link.
That would be true.
Yeah. So what I just did here is I took our lecture. Oh, connecting to iCloud. This is gonna break. Look at that. Shared. So now I should be able to go into Angel, right?
Should be able to.
And just put the lecture set up.
Yeah. Happy with my job. I cannot get Eclipse open at all. Keeps coming back with an exit code 13.
Oh, nice.
Yeah.
No, it's just slow. It's not down, but it might as well be.
Sorry, I'm just downloading a lot of things.
It's just cranky.
Gotta get those pictures.
So I'll put this slide set up, and it should. The theory is it should continually update whenever we. Yeah.
It's really gonna get cartoony now.
Yeah, well, oh wait, we're here.
This is bad as hell.
Even worse.
Yeah, we're okay. Link. Slide set. I'll put the link there. So you should be able to just click on it, but sometimes clicking doesn't work right.
Yeah, CS happened.
So I also gave it to you. Yeah, see it. Loading. So you even get the nice little Apple logo.
Shiny. Wonderful.
All you need is an iCloud account.
Actually, it'd be really funny if they did the same thing when the Apple Store shuts down when they're putting something else. We'll be back soon, and just keeps going through all the different languages for your slide set. Oh, it's in beta.
Uh-oh.
It's always on beta for the web version.
Welcome to Keynote for iCloud. Thank you.
Hey, mine looks after yours.
I don't want to enter a public screen name. All right, there. So now you have the slides. And you know how to spell my name. And you have my phone number.
Who's Code Boy?
Oh, that would be Largan. All right, so those are up. I'll try to do that for my other classes too. Okay, what am I doing? We need to pick up where we left off. All right, so we had been doing string parsing, correct? What was our last homework assignment we did?
That was a long time ago.
Expect us to remember?
Gotta get on the angel.
All right, well here I'm just gonna.
It'll take a long time.
All right, so we want to talk about data storage. So when we talk about storing information, we have some options. So option number one for storing information is a variable, right? Variable. And actually specifically we're going to say primitive type variables, because that's what we know about right now, okay? So this is kind of coming out of our toolbox, okay? What's good about primitive type variables? They're really easy to create, correct? Int a equals 5. We just stored 5 in a variable named a. Done. Okay? But there's some limits to primitive type variables. So for instance, on the exam, we said, well, I said, some of you said, primitive type variables are only capable of holding a value. What does that actually mean? So we just said they can hold a value. We just created that scenario, int a equals 5. So a is the name of the variable, and it's holding the 5. Holding the value. But we're saying that primitive types can only do that. What does that mean? What is it that they can't do? They don't have methods. So you cannot, and this was on that one question that I curved back into the exam. Some people tried to take that character C and they tried to say C dot to uppercase. C is a primitive type. It doesn't know any extra magic tricks. We have to utilize that variable and pass it to somebody else who can do magic tricks. Because primitive types on their own cannot do any magic. They can't call any methods. All they can do is hold a value. Make sense? And given that fact, that's the telltale sign that strings are not primitive types. Because strings do have magic tricks they can do. They can tell us their length. They can give us a character in a particular place. They have index of. They have 2 uppercase. They have 2 lowercase. They got a bunch of other crap that we haven't even talked about. All right, so primitive type variables can only hold the value. But from a data storage perspective, oh, are you changing crap? I thought I set it up that you couldn't change crap.
Largan is.
Modified on iCloud. Did you change something?
Damn it.
Did it let you?
It was. No, it's not.
Well, it shouldn't have let you.
I think you had to add a password. You didn't add a password.
This is the presentation unavailable.
I was totally trying to have a picture of that.
View share settings. Oh, hold on. I thought.
I was so close.
More a second.
It is a beta, after all.
Yeah, well, that's weird. Actually, I shouldn't have to change the link now. Share settings, view only. All right, try it now. We'll let you change it now.
Let me get back on that. I'm refreshing it just to make sure the changes take place.
All right.
Takes me
All right, so why don't we go with this guy, the one on my Mac. Lost everything. We actually did lose that slide. All right.
Much information on it though.
All right, data storage. So we have primitive type variable.
Whoa.
Keyboard having issues?
No, fingers. Primitive type variable. So primitive type variable, they, from a data storage perspective, allow us to store exactly one value.
You have to pick a new version.
version to keep with the link. Yeah.
Who?
You have to pick a new version to keep with the link now, so the versions are out of sync, so I can't access it.
It won't even let you open it?
No,
We'll have to work on this after class today.
We might have now, I think.
Oh, you can just
Just
figure it out now.
It is opening or is not opening?
It's loading. Now it is.
It's good?
Yep.
All right.
Question is it updated?
Well, maybe it'll come soon. Keep me posted. All right, so data storage here. I just saved, so possibly it'll pop up
It is
now.
view only now.
All right, so data storage. Weakness of primitive type variables from a data storage perspective, or maybe a weakness is the wrong term, just kind of a fact, keep in mind, is they only allow us to hold one value. Well, sometimes you want to hold more than one value. So another example of data storage we have are strings. Strings allow us to hold a collection of chars. In a read-only manner. Collection of chars in a read-only manner. That has limitations for us. So, for example, if we come back in here and we say string s is equal to hello, we can print out s.charat2. This is bucket 0, this is bucket 1, this is bucket 2. So this is going to print out that L, correct? So we can read from the contents of that string. But what we can't do is we can't say s.charat2 is equal to a B. It's read only. Now, this is for multiple reasons. So besides strings being read only, this line doesn't even make sense. Whenever you see a line of code, we need to resolve that line of code, correct? S.charat2 boils down to what? L. So what I'm trying to do is I'm trying to change language. I'm saying, you know what, from this point forward, the literal L, the character lowercase l, will now be an uppercase B. I have decreed it. Java's not going to let us get away with that. Can't start changing up the language. Make sense? Just like we can't say a 5 is now a 7. FYI. Okay? Not going to like that. So, ultimately, let me just that. Beginning programmers tend to like to write stuff like this because in their mind they think this is what they want to do. They want to change whatever's at bucket 2 in that string to this guy. We forget about how things resolve. So that's why I'm giving you that rule of thumb. Whenever you look at a line of code, always fully resolve it. If we're looking at this line of code right here, we need to resolve this guy before we can print. So we're going to resolve this guy down to the literal lowercase l, and then we'll print that char, the lowercase l. That make sense? That's the order of operations. So strings are read-only. If we do want to change whatever's at bucket 2 of hello to a B, what do we need to do? Use a loop and build a brand new string. Keep everything before bucket 2, replace bucket 2, keep everything after bucket 2. Becomes a headache, correct? We could pull it off. We can write a method that does that. You know, we can have a method called replace at pos, or something like that, that takes in a string, the position we want to replace, and what we want to replace it with, the char, And we can do that method so that we have a, reusable chunk of code that allows us to treat strings as if they were read-write. But strings innately are read-only. Now, does that mean strings are bad? So strings have that limitation that they're read-only, but strings have a lot of powerful tools associated with them. So we might say many problems that we are solving with strings don't necessarily involve us modifying strings in the middle. All the modification problems we've done with strings have dealt with building brand new strings for reasonable reasons. Remove all the digits. All right? If we have a set of data that we're storing where we might need to manipulate portions of that data often, strings are probably not the best way to store that stuff. But unfortunately for us, that's where our current toolbox ends. So we have something called an array. Arrays hold a collection of like data in a read-write manner. That is, arrays, an array that is a lot like a string would be an array of chars. Okay? Would be an array of chars. So in that case, we have a collection of char primitive types, like data. That's what I mean by like data. All the same data type. Okay? And as we get into inheritance and stuff, we're going to see that that statement is 100% true, but we do have some powerful tools for storing a bunch of stuff that are not necessarily identical, but all have a common ancestor. Something like that. Not something for us to worry about now. For right now, we want to think about arrays at the primitive type level. Collections of ints, collections of chars, collections of booleans, that kind of stuff. But there's no reason why we can't hold a collection of strings, string object types. Okay? But right now, we want to think about arrays as they compare to strings. So, for example, if I have string s is equal to hello, and I want to build an array capable of holding all the characters that are in hello, I'm going to say char array. Now here, I'm going to review something here for you real quick. Defining a variable. Type var name equals value. That's the generic syntax for defining any variable. Correct? So, the type, I'm introducing a new type to you today, will be a char array. Open square bracket is what dictates something as being an array. This happens to be an array capable of holding char primitive types. If I wanted it to hold int primitive types, I'd put int out front. If I wanted it to hold strings, I'd put string out front. And we've seen that before, right? With our command line arguments, this guy took in a string array, a collection of strings. But for our example here, we're going to take in a collection of chars. We're going to create a variable that is a collection of chars. We're going to call it AR. And this guy is going to be a new char array of size s dot length. All right, so let's look at what we just accomplished. I'm going to draw pictures here. I'll go with this guy. So I have string s is equal to hello. Then I have char array AR is equal to a new char array s dot length. Okay? What is s dot length? What does this boil down to? What does this resolve to? Which is So in this particular case, I have a string named S, which holds a pointer to an actual string in memory called hello. When I call s.length, this will boil down to an int. It will boil down to an int representing the number of characters that are in S. And in this particular example, that number is 5. There are 5 characters in hello. So this will boil down to 5. All right? What's the new keyword? Real estate agent goes and gets us some new memory address in memory. Enough memory to hold this many of these guys. And we'll look at that more here in a few minutes. Well, maybe possibly next time, but we'll see. Now I'm going to show you what was just built. Oh, it was the right button. Boom. This picture's for you. All right. So this created a variable named AR, which is a pointer. That is, it holds a memory address because of the new keyword. And it will point to the beginning of this new construct, this new structure that we just built. And this structure will be a bunch of memory in a row. How many? 5 buckets. Why 5? Because that's how many we told it to build. Each capable of holding a char. Okay? Now, realistically, AR is going to have a value. So let's just say this is memory address 100 for our example here. So that's actually the pointer. So AR is a variable of type pointer, which holds a memory address. So it holds, let's say in this example, the memory address 100, which points somewhere up in memory where this new array has been built. And this new array is built in what's called contiguous memory. That is memory in a row. How big are chars? I think it was day 1 from our slide set. Remember we had all the different primitive types? A byte is 8 bits. How big is a char? 16-bit. A char is a 16-bit unsigned integer, right? So it's 16 bits big. How many bits do I need to store 5 chars? 80 bits. Need 80 bits. So the task that was assigned to the new keyword here is I need you to go out and get me enough contiguous memory to hold this many of these guys. So in this case, we told the new keyword, go and find me 80 bits in a row. That make sense?
So contiguous just means
In a row. Contiguous means in a row. So it just so happened in our example here, the new keyword said, hey, found you a great plot of land. Memory address 100, coast is clear. You have 100 all the way up to 179 for all our bits, something like that. Now, you told me that each of these chars takes up 16 bits. So I'm going to steal this guy. Change the color here. So this is memory address 100. This is in, we're gonna jump by bytes. Okay? This is memory address 102. 16 bits is 2 bytes. This is memory address 104, 106, 108. Make sense? So we have the containers for actually holding our data, which we are currently not using. Everything we're doing here is what was created by this single line right here. All right, so we got a memory address created from the new keyword, which is a pointer to someplace up in memory where this actual construct lives. Here's our data. It is indexed just like string 0, 1, 2, 3, 4 for an array with 5 containers in it, index 0 to length -1. And its actual memory footprint is from the starting address to the ending address all in a row, contiguous. Now, I'm going to go ahead and I'm going to fill up AR with the characters from S. So I'll say for int I is equal to 0, I is less than S dot length I plus plus. So we'll spin through every character in S, and we'll set AR at bucket I equal to. So already we're seeing that we can write to an array. So I'm saying AR at bucket I is going to equal S dot char at I. So I'm going to get the current character we're interested in from S and store it in bucket I of AR. So as we go through here, what that'll do is it'll store NH, NE, NL, NL, and NL. Make sense? So now we filled up our array. Now, we could have filled up our array this way, but we know that S has 5 characters in it. We also know that AR has a length of 5 because they were built in terms of each other, correct? We built AR using the length of S. So rather than saying S dot length here, we could have said AR dot length. Now, notice that I did not put an opening and closing parenthesis there. It's just length, like this. All right? That means that this is not a method, it's actually a variable. It's actually something called a field. And we'll talk more about those when we talk about objects shortly. But for right now, just understand from a trivia perspective, there's a difference between the length method of the string class and the length field of arrays. But they both ultimately return us the same kind of value. How many buckets are in this guy? All right? That makes sense? So, what we've done up to this point is we have filled up our array AR with all the contents of S. We can access those guys at bucket 0, 1, 2, 3, 4. And here's the memory addresses associated with it. All right? Next time, which will be next Tuesday, correct? Yep. Thursday, Friday, we're on break. So next Tuesday, somebody remind me, I want to come back and show you how to access elements of an array, specifically how that works with memory. Okay? If you didn't know about pointers before, you're going to know about pointers now. All right? I will see everybody when I see ya.
Did you get your hot tub work?